Hello, hi everyone. Welcome to the Student the Brand. This is your Siva sir. Today topic is light reflection and refraction. Light reflection and refraction. So now in this reflection and refraction, first of all, we'll discuss about plane mirror. So I'm taking this a plane mirror. I'm considering the plane mirror. So you can see on the screen. So this is a plane mirror. The light which is incidenting on the surface. So this is the incident ray. I am taking this incident ray. The light which is incidenting on the surface. This is called incident ray. Incident ray. And the light which is reflecting back. So here, if you take, this is the reflected ray. Reflected ray. Reflected ray. And I am considering this a plane surface. I am taking the plane mirror here. Plane mirror. Plane mirror. So the line which is perpendicular to the surface, that is called normal line. I am taking this a normal line. Here is a normal line. The angle between incident ray, here is it. The angle between incident ray and normal line is called angle of incidence, and the angle between reflected and normal line is called angle of reflection. And the line which is going through the surface, or the initial direction, if you extend this one, this is the initial direction of the incident ray. The angle between reflected ray and initial direction of the incident ray are undeviated line. So that is called angle of deviation. Angle of deviation. Okay. So the bouncing back of the light. So here is the first point is about reflection. So reflection is nothing but the bouncing back of the light from the reflecting surface is called reflection. The bouncing back of the light from the reflecting surface. So when light incident on it, it will be reflected back. This entire phenomenon is called reflection of light. And coming to the laws of reflection. So here I will tell about the terms what we used in the plane mirror. One is incident ray. Incident ray, the light which is incidenting on the surface, incident ray. Reflected ray, the light which is reflecting back from the surface. And plane mirror, highly polished smooth surface. Angle of incident, angle between incident ray and normal line is called angle of incident, and angle between reflected ray and normal line is called angle of reflection, and angle between reflected ray and undeviated line is called angle of deviation. Okay, so these are the points. And one more thing also, glancing angle of incidence will be there. The angle between incident ray and a plane surface is called glancing angle of incidence, and the angle between reflected and plane surface is called glancing angle of reflection. So here it is, we will consider glancing angle of incident and glancing angle of reflection. So incident ray and plane surface, reflected and plane surface, based on that one, so we are talking about glancing angle. And loss of reflection. So next one we'll discuss about loss of reflection. Loss of reflection. Loss of reflection. Here is the point. Loss of reflection. Now first point is angle of incident equal to angle of reflection. Angle of incident is equal to angle of reflection, and incident ray, reflected ray, normal line lies on the same plane. So here is the point, angle of incident equal to angle of reflection, incident ray, reflected ray, normal line. So whichever the dotted line we are drawing here, so we did here, this one, this is the normal, so here is the normal line. Okay, so that is a normal, so all lies in the same plane. So these are the laws of reflection. Laws of reflection, angle of incident equal to angle of reflection, incident ray, reflected ray, normal line lies on the same plane. So these are the laws of reflection. And here angle of deviation, so we'll talk about angle of deviation. This is angle of deviation, so this is the angle of deviation, this one. This angle of deviation, how we have to take? So normally this linear angle, that is 180 degrees. that here if you observe here, that if you consider, so angle of incident is there, angle of reflection is there, and angle of deviation also there. So totally angle of incidence plus angle of reflection plus angle of deviation equal to 180 degrees. So as you can see here, so this is a line, so this line, it's okay, on the line angle of incident is there, angle of reflection is there, and angle of deviation also there. Three angles if you add, you'll get it 180 degrees. So according to laws of reflection, so here we discussed it, according to the laws of reflection, angle of incident equal to angle of reflection. Then we can take angle of incidence plus angle of incidence plus angle of deviation equal to 180 degrees. 180 degrees. So now I am taking angle of deviation equal to 180 minus 2 angle of incidence. So we can also take, instead of angle of incident, we can take angle of reflection also. Then we'll get angle of deviation equal to 180 minus 2 angle of reflection. 2 angle of reflection. So both, if they give angle of incident, we can use this formula to find angle of deviation, and here if they give angle of reflection, we can use this formula and to find angle of deviation. So that is about angle of deviation. Coming to the reflection, types of reflection. Coming to the reflection, so types of reflection. So just now we discussed types of reflection. Reflection, we discuss the bouncing back of the light from the reflecting surface is called reflection. So here types of reflection, there are two types of reflections are there. One is regular reflection, regular reflection. Second one is irregular reflection. First one is regular reflection, second one is irregular reflection. Irregular reflection. So if you consider regular reflection, so regular reflection takes place on smooth surface. I am talking about regular reflection. Regular reflection, so put the heading regular regular reflection, regular reflection. So I'm talking about regular reflection. So regular reflection takes place on smooth surface. I'm considering this smooth surface. I'm taking a plane mirror. Okay. So when the parallel beam of light incident on it, I'm taking the parallel beam of light. So here all light rays are parallel to each other. So the incident light rays are parallel to each other. Those incident on the surface, then reflector light rays also parallel to each other. So then reflector light rays also parallel to each other. Then this type of reflection is called regular reflection. So I am considering here, this is a parallel beam of light, parallel beam of light, parallel beam of light, parallel beam of light rays, light rays, light rays. So whereas reflector light rays, so these are the reflector light rays. Reflector light rays also parallel to each other. So here incident light rays, these are incident light rays. So those are incident parallel beam of light rays, we can say. Here reflected beam. Reflector light rays also parallel to each other. Reflected beam. Reflected beam. So this also parallel to each other. This type of reflection is called regular reflection. So regular reflection takes place on smooth surface. Regular reflection takes place on smooth surface. Smooth surface. Surface. Regular reflection on regular reflection takes place on smooth surface. Here I am taking the smooth surface is plane mirror. What type of mirror is plane mirror? Okay, so I'm taking the plane mirror, right? So this is about regular reflection. So I hope you got it. Next one will go to the irregular reflection. Irregular reflection or diffused reflection. Irregular reflection is also called diffused reflection. So How the surface will be there, how the irregular reflection takes place, we'll see now. I am considering the surface here. This is a rough surface. So here I am taking this one here like this. Okay. So incident beam is parallel. So if the light rays are incidenting, those light rays are, whatever the light rays are incidenting on it, those are parallel to each other. But reflector light rays are not parallel to each other. So they'll move in different directions like this and like this and like this. So on different direction. It won't be parallel. So here you can see this is the incident beam parallel to each other, but reflected beam is not parallel to each other. So that is called irregular reflection or also diffuser reflection. Irregular reflection takes place on rough surface. So this is the rough surface. Okay, and this is about irregular reflection. And the next one coming to the object and image. So object and image. So I'll talk about object and image. So that is about completely related to plane mirror itself. So I am considering now, so this is a plane mirror. I am taking the plane mirror here. Okay, so plane mirror I am considering, and this is a normal line, plane mirror and normal line. I am considering the object here. This is the object. This is a real object. So object is real. So the light ray is, which is how many light rays are required to form the image of the object? Minimum 2 light rays are required to form the image of the object. That's why I am taking 2 light rays. So after incidenting, the light rays will be reflected back. Okay, so this is the incident ray 1, incident ray 1. Here also incident ray 2. This incident ray 1, incident ray 2. So this is the reflected ray 1 and a reflected ray 2. So if you are extending those light rays, the light rays are meeting at one point on the principal axis. So if you are taking this light rays, if you extend this, these are the reflected light rays I said, no, these reflected light rays, those are extending and meeting at one point. So their image will form, that is a virtual image. What is that? What type of image is virtual image? So we are extending the reflector light rays. After extending those light rays, the light rays are meeting at one point on the principal axis. Their image will form. That image is called virtual image. Here, the real object, from the real object, light rays are coming. Those are incident rays. So after reflection, reflector light rays are extending. Those are meeting at one point on the principal axis. That is called virtual image. So, and one more point I am taking here. So you can observe. So I'm taking the two diagrams. So here is the plane mirror. One side is coating one and silver coating. Another side is reflecting surface. So light rays are coming from infinity. So I'm taking this infinity. So after reflection, light rays will meet at one point. So on the principal axis. So I'm taking this. So those are after reflection, those are meeting at one point here. Okay. So if you are extending this incident rays are meeting at one point. Incident rays are meeting at one point. Incident. So this is incident ray 1. Here also incident ray 2. Incident ray 1, incident ray 2. This is a reflected ray 1 and reflected ray 2. Reflected ray 2. So here extending the incident ray, this is a virtual object. Here real image. Here is a real image. So here you can observe, here object is real, image is virtual. Here image is real, object is virtual. So by this one we can conclude that here is object and image. If object is real, image is virtual. If object is virtual, image is real. So we have to remember this point, very very important. If object is real, image is virtual. If object is virtual, image is real. So that is about object and image, or the point of intersection of, so here reflector light rays, the point of intersection of reflector light rays is called real image, the point of intersection of reflector light rays. So directly the reflector light rays are meeting, that's why here it is a real image it's forming here, whereas the point of intersection of extended reflected light rays. So this is the reflected light rays. So these are the reflected light rays. We are extending those reflected light rays. Those are meeting at one point on the principal axis. That is called virtual image. Extension of reflected light rays is virtual image. So actual meter of reflected light rays is real image. Here also same thing. So the light rays, incident light rays are coming from the point that is a real object. So if you are extending the incident rays, so this is the incident ray 1, incident ray 2. So we are extending those incident rays. So those light rays are appearing to meet. So appearing to meet. We are drawing the dotted lines means we are assuming appearing those light rays will meet at one point. So that's why it is virtual image. So okay. So here is the virtual image, virtual virtual object. This is the virtual object. Here is the virtual image. That is about object and image. And coming to the plane mirror characteristics. So the nature of the image formed in the plane mirror. So here is the plane mirror I am taking. Plane mirror. Plane mirror. Okay. So here I'm considering this plane mirror. This is the plane mirror. So light rays, if you are coating is there, this is a coating, this is a coating, and so this object I am taking, this object height, AB is the object height, and one light ray I am taking. How many light rays are required to form the image of the object? Minimum 2 light rays are required. So that's why I am taking 2 light rays, one light ray and another light ray, it will be reflected back. And here also, so one light ray I am taking like this and it will be reflected back. Okay, so here is the direction of the incident ray and reflected ray. So if you are extending these light rays, so the image will form here. The image will form. What type of image will form? Virtual image will form. Virtual image will form. So here is the dotted line. Here also dotted line. So this is a plane mirror. So I'm taking here is a dotted line. So this is the AB height of the object, and A dash B dash is the height of the image. So AB is the height of the object. So this height of the object, and here is the height of the image. So here we have to take first point number 1 is height of the object is equal to height of the image. In the plane mirror, so if object is real, image is virtual. If the image is real, object is virtual, vice versa. And the second point is so here image is virtual, erect and same size. Virtual, erect and same size. In this case, whatever object is real I am taking, object is real. So image is virtual, erect and same size. So object, so height of the object equal to height of the image. And if you are taking the distance, so the distance between object to mirror is called object distance. The distance between object to mirror is called object distance. The distance between object to image, so the distance between mirror to image, this is a mirror I am taking, this is a mirror, mirror to image. So mirror to image is called image distance. The distance between object to mirror is called object distance. The distance between mirror to image is called image distance. Here object distance is equal to image distance. Object distance is equal to image distance. So first one is height of the object equal to height of the image. Second one is object distance is equal to image distance. Third one, so it shows lateral inversion. So what is a lateral inversion? The phenomena of conversion of left side of the object appears to be right side of the image, right side of the object appears to be left side of the image. So mirror image. So simply we can say mirror image. So if I am taking R here, so it appears like this. Left side of the object appears to be right side of the object appears to be left side. So if suppose I am taking this is left and this is right, so here it is appearing like this. So you can observe here is the left, so there it is. So here is the left is appearing here, so this side is appearing right side. This left side portion whatever it is there, that side that is appearing in the right side. So in the right side portion appearing in the left side. So this mirror image is called lateral inversion, is called lateral inversion. So that is about plane mirror and nature of the image formed in the plane mirror. Next one we'll talk about spherical mirror. So next one we'll talk about spherical mirror. Spherical mirror in the sense the mirror which is in the form of curved shape. Spherical mirror. Spherical mirror. Spherical mirror. Okay. So here is the term spherical mirror. So I'm taking this a portion. So I'm taking this a curvature. It is a curvature. From here I'm taking a small portion. So this is a sphere. From here I'm taking the small portion. This is a curvature. This is called curvature. According to the coating. According to the coating. So if I am coating like this, okay. So this silver coating is outside, reflection takes place inward. Reflection takes place inward. So that type of mirror is called, so reflection is taking place inward. So you can observe here, reflection is taking place inward. So this type of mirror is called concave mirror. Concave mirror. Concave mirror is also known as converging mirror. Converging mirror. So why we are considering it is converging mirror? Concave mirror is also called converging mirror. So whenever the light ray incident on it, after reflection, light rays are converging, means moving towards the principal axis. So that's why it is converging mirror. So whereas one more mirror I am taking, so that is I already said according to the reflecting surface. So it divided. So here you can see I am taking this is the convex mirror. Convex mirror. Convex mirror. Convex mirror is also called diverging mirror. Diverging mirror. Convex mirror is also called diverging mirror. Diverging mirror. So whenever light ray incident on it, so I'm considering like this. So those light rays are reflected back like this. So I'm considering like this. So after reflection, light rays will move away from the principal axis, away from the principal axis. So this is a principal axis, away from the principal axis. The light rays will move away from the principal axis. So here is the converging mirror. Convex mirror, that is known as diverging mirror. That is known as diverging mirror. So this is about two types of mirrors. So spherical mirrors. And next one, here is the point. So in these mirrors, we'll talk about terms. Terms used in the spherical mirror. Terms are nomenclature. Terms used in the spherical mirror. Terms used in the spherical mirror. Spherical mirror. So what are the terms we used? So we will see. So I am considering now. So this is a concave mirror. Concave mirror I am considering. Okay. So the actually it is a part of the sphere. So if you take, it is a part of the sphere. I am considering like this. This is a part of the sphere. The midpoint of the mirror is called pole. The midpoint of the mirror is called pole. And the center of the imaginary sphere. Here you have to understand. So this is the center of the imaginary sphere in which mirror is a part. Center of the imaginary sphere in which mirror is a part. So that is called center of curvature. One is pole. Second one is center of curvature. Center of curvature, center of curvature, and third point is radius of curvature, radius of curvature, radius of curvature, and fourth one is, so here The distance between center curvature to pole. The distance between center curvature to pole is called radius of curvature. So from center to pole. So this is called radius of curvature. Radius of curvature. R I am denoting capital R. So after reflection, all light rays will meet at one point on the principal axis. On the axis. So this is called a focus. This is called focus. Actually, the line joining of center curvature and pole. So this line is there. Whatever the line is there, the line in joining of center curvature and pole is called principal axis. So this is the principal axis. Principal axis. Principal axis. The line joining a center curvature and pole is called principal axis. So yeah, here after reflection, all light rays will be reflected back and meet at one point on the principal axis. That is called principal focus. Principal focus. So here principal axis, principal axis, principal axis, and fifth one is so principal focus, or simply we can say focus. So sixth one is the distance between focus to pole. Here you can see the distance between focus to pole. The distance between focus to pole is called focal length. So focal length, the distance between focus to pole is called focal length, and the width of the mirror is called. So this is the width of the mirror. I am considering this is the width of the mirror. This one is called aperture. So seventh one is aperture. So the width of the mirror or diameter of the mirror, or reflecting surface. Once again, the midpoint of the mirror is called pole. The center of the imaginary sphere in which mirror is a part, that is called center of curvature. The distance between center of curvature to pole is called radius of curvature, and the line joining of center of curvature and pole is called principal axis. And after reflection, all light rays will meet at one point on the principal axis, that is called focus. So the distance between focus to pole is called focal length, and the width of the mirror is called aperture. Width of the mirror is called aperture. So these are the terms used in the spherical mirror. Terms used in the spherical mirror. Next one. So normally if you want to draw the diagram, so we need ray rules. We need ray rules. If you want to draw the image formation of any object, we need ray rules. So we'll talk about ray rules. First one I'm considering. First one I'm taking. So this is a concave mirror. So here is a pole and focus and center of curvature. So one light ray I'm taking here. So after incidenting, it passes through the focus, passes through the focus. So one light ray I'm taking, it coming from infinity. After reflection, it passes through the focus. So even for a convex mirror also, even for convex, this I am taking the concave mirror, this side I am taking the concave mirror, this is the concave mirror, here is the convex mirror, convex mirror. So even for a convex mirror also same thing. So if you take this a convex mirror, so here is the pole. So here is the pole, focus and center of curvature. So one light I am taking here. So one light I am taking like this. So after reflection it passes through like this. So if you extend this one, it passes through the focus. And the second point is, so in concave mirror, light ray same first one, reverse of the first one, reverse of the first one. So here is the pole. So first one you can observe. So I am considering the pole. sorry. So here, so this is the pole and I am considering the focus. Here is the center of curvature. Here is the center of curvature. One light ray I am taking. So as I said, no. So if the light ray coming from infinity after reflection passes through the focus, here also same thing. If you are taking light ray passing through the focus after reflection, it passes towards infinity. And here also second one same thing. So here is the pole, focus, center of curvature. So what type of mirror it is? Convex mirror. One light, say as I said, so it will passes through the focus. So if you are taking, it passes through the focus. After that, it passes towards infinity. So these are the two ray rules. And third one for concave mirror. Third one for concave mirror. So I am considering concave mirror like this. So pole, focus, center of curvature. So if the light ray incident at the pole, it will be reflected back. So even here also same thing for a convex mirror. So you can write once. So here is the concave mirror. Here is the convex mirror. So now if the light ray incident at the pole, as I said, pole, focus, center of curvature, it will be reflected. And fourth one you can see, if the light ray passes through the center of curvature, pole, focus, center of curvature, the light ray passes through center of curvature. So if you are taking like this, so here also fourth one. So here is the pole, focus, center of curvature, pole, focus and center of curvature. If the light ray passes through center of curvature, it will be reflected back. Here it will be reflected back like this. Here also if you are taking like this, it will be reflected back. So if you are considering like this. Okay. So these are the four ray rules of concave and convex mirror. So now we'll discuss about image formations. So we'll go with the image formations, how the image formations will be there, how it will produces. So we'll talk about now. So everything about image formations. So how many light rays are required to form the image of the object? Minimum 2 light rays. Every time, so we are drawing the image formations, minimum 2 light rays are required. So image formations of concave mirror. Image formation by concave mirror, by a concave mirror. So how the image will form? How the light? See, just now we discussed about light rays. So how the light? If you take different light ray, how the reflector light ray will go. So here I am considering. So I am taking this concave mirror. Here is the pole, focus, and center of curvature. One light ray I am taking like this. So after how many light rays are required? Minimum 2 light rays. Light rays are coming from infinity. After reflection, those light rays are meeting at focus. So here I am considering, okay, object at infinity. So image is formed at object I'm considering, I'm taking object I'm taking at infinity. So image is forming at focus. What is the nature of the image? Real, inverted, real, inverted, and highly diminished. Highly diminished image is formed at focus. So highly diminished image is formed. So second one is, I'm taking the second one, second image formations. So I'm considering the concave mirror. Concave mirror I'm considering. So here is the pole. So pole, focus, center curvature. So object is placed beyond center curvature. I'm taking the object beyond center curvature. How many light rays are required? So minimum 2 I said. So one light ray I'm taking like this. It passes through focus. So another light ray I'm taking through center curvature. So those will meet. Both will meet between C and F. Between C and F. Image will form between C and F. Here is the image like this. So I'm considering like this image. So object beyond C, object is beyond C, image is between C and F, image between C and F. Nature of the image is real inverted, and diminished. Actually it is not enlarged, diminished. Compared to the object, image size is decreased. That is nothing but diminished. So nature means real and inverted. Nature means real and inverted. Size means diminished. So next one, third image formation. Third, third image formation. We'll go with the third. Third one is, I am taking like this. So here is the pole, focus, and center curvature. Object is placed at center curvature like this. So image will form. So where image will form? At center curvature itself. So I'm taking like this, and one more light ray you can take at the pole. So it will be reflected back. Those will meet here both. So you can consider. So the light ray will be after reflection. So you can check here, and after reflection passes and meet at here. Okay, object I am taking at C. Object I am taking at C. Image also at C only. Nature of the image is real, inverted, and same size. Real and inverted and same size. So wherever the object is placed, image also will form at same point. Okay, so that is about C. And the fourth one, so we are talking about fourth one. So I'm considering like this. So pole. So here is the pole, focus, and center curvature. Pole, focus, and center curvature. Object is placed between C and F. Object is placed between C and F. One light I am taking like this. After reflection passes through the focus like here, and one more light I am taking here at the pole. After reflection, those light rays will meet beyond center curvature. So here is the point, so reflected point. So after reflection, those light rays will meet beyond center curvature. So here is the point, so those will meet. So here we have to understand, object between C and F, image will form beyond C. Nature of the image is Real, inverted and enlarged. Real, inverted and enlarged. Object between C and F, image will form beyond C. Nature of the image, real, inverted and enlarged. And the next one, fifth one you can see, fifth one. So object is placed at F. So here is a fifth one, last second one we can say. So 6 cases are there. So this is the pole, focus and center curvature. Object is placed at F. Image will form at infinity. So one light I am taking, it passes like this, and another light I am taking here, it will be reflected. So those are parallel to each other. So we assume light rays will meet at infinity. We assume light rays meet at infinity. Object at F, image formed at infinity. Nature of the image is real, inverted and highly enlarged. Real, inverted and highly enlarged. So last case, so we are going with the last case, very important. So I am taking the concave mirror like this. Okay. So here is a concave mirror, like I am taking. This is the pole, focus, center curvature. Object is placed between F and P. Object is placed between F and P. One light I am taking like this, it will be reflected back. So it passes through the focus. So here is the focus, it passes through the focus. So here is the focus. So we can take, yes, so it will passes through the focus. I'm taking like this. Sorry. So we'll draw once again. So after reflection passes through the focus like this. And one more light I am taking. So it will passes through center curvature itself. Like here also I am taking like this. Okay. So it will be passing and reflected back. So if you are extending those light rays, those will meet behind the mirror. So like here, like this, here it will form. I'm considering like this. So image will form behind the mirror. Okay, so here I'm taking the point once again. So if you are, so image will form behind the mirror. Object between F and P. Nature of the image is image. Virtual and erect, because it is behind the mirror. Virtual, erect and enlarged. Compared to the object, image size is increased, so that's why it is enlarged. Very very important. Then concave mirror. So this is about concave mirror. Where we will use concave mirror? So we'll use here uses of concave mirror. We'll go with the uses of concave mirror. Concave concave mirrors. Concave mirrors. So where we'll use concave mirrors? Torches. First point is torches, searchlights, vehicles, torches, torches. Second point is searchlights, vehicles, shaving mirrors to see large image of the face. The dentist use concave mirrors to see large image of the teeth of the patients. Large concave mirrors are used to concentrate sunlight to produce heat in solar furnace. Solar furnace. Solar furnace. So these are the all uses of concave mirror. So we'll go with the convex mirror. Only in convex mirror, only two cases are there. Convex mirror. I am taking like this convex mirror. So here is the convex mirror. Pole. So here is the pole, focus, and center curvature. So object is at infinity. So here is the image formation by convex mirror. Convex mirror. Okay. So light rays I am taking. So one light ray I am taking like this. After reflection it passes like this, and another light ray I am considering here. It will be reflected back. So if you are extending those light rays, will meet at one point on the. Okay. So those light rays will meet at one point on the principal focus. Okay. Object is at infinity. Image is formed at focus. Nature of the image is virtual, erect, and diminished. Virtual, erect, and diminished. Because small size of the image will form, that is virtual image. And the second case is object is placed. So second case for convex mirror, object is placed anywhere between object. So I'm considering like this. So here pole, focus, pole, focus, center curvature. Object is placed anywhere between infinity and pole. One light I am taking like this, it reflect back. So another light I am taking like this, so it will be incident, it reflect back. And if you extend this light rays, those light rays will meet between P and F, between P and F, between P and F. So object between P and infinity, P and infinity. So anywhere we can place, not only in one place, we can place anywhere. P and infinity. So image between P and F, image between P and F. Nature of the image is virtual, erect, and diminished. Virtual, erect, and diminished image will form. So in a convex mirror, convex mirror. Now, so we can see uses of convex mirror. Uses of convex mirror. So what are the uses? Uses are nothing but used in rear view mirror, as rear view mirror in vehicles. Rear view mirror in vehicles. Okay, rear view mirror. Second point is used in diffusing the light, diffusing the light from the bulbs in the floodlights, used as a shop security mirrors, used in staircase mirror on the double-decker buses. Convex mirrors are used in reflecting telescope. So these are the uses of convex mirror. Shop security mirrors also. Security mirrors, we can say security mirrors. These are the uses of convex mirror. So next one, sign conventions. Sign conventions are very important. So even in the problems also we'll use sign conventions. Sign conventions are here, you can see I'm taking the convex mirror like this. Convex mirror. So pole, here is the pole, focus, and center curvature. So what type of mirror it is? Convex mirror. I'm taking convex mirror here like this. Okay, so this sign conventions also called new Cartesian sign conventions. All measurements will be considered from the pole. First point is all measurements will be considered from the pole in the direction of incident rays. So because as I said, if you place the object here, so image will light rays will come like this, but I am taking from this point. So in this direction all are positive. So what are those? object distance, image distance, focal length and radius of curvature all are positive. Opposite to incident rays, because incident rays are moving like this, opposite to incident rays all are negative. So what are those? Object distance, image distance, focal length and radius of curvature all are negative. Above the principal axis, height of the object, or height of the image positive. Below the principal axis, height of the object or height of the image negative. So above the principal axis positive, below the principal axis negative. So as we can say the coordinate axis, we can say origin, positive x-axis and negative x-axis, positive y-axis and negative y-axis. So with the comparison also we can remember. For remembering sake I am saying all measurement will be taken from the pole in the direction of incident rays, all are positive, opposite incident rays negative, above the principal axis positive, below the principal axis negative. So this is about sign conventions, sign conventions, new Cartesian sign conventions also we can say. So simply new Cartesian conventions. Next one we will talk about mirror formula. Mirror formula is nothing but the relation between object distance, image distance and focal length. So 1 by f equal 1 by u plus 1 by v equal to 1 by f. So this is the mirror formula, or we can take 1 by f equal to 1 by u plus 1 by v, mirror formula. And magnification is nothing but height of the image by height of the object, that is nothing but minus v by u. So for mirror, so this is about mirror I am talking, that is a mirror formula. And mirror magnification. So this is about reflection of light, So next part will go with the refraction, reflection of light, on spherical mirrors and plane mirror also. So next part will work out on refraction. So until then, keep watch the videos and do like, share and subscribe my channel. Thank you so much. Thank you. Yours, Shiva sir.